Well, colleagues, thank you very much for inviting me, and what a great presentation for Astrid and Chris on fundamental life science about how it matters for the ocean system and what's still to be discovered. I think it made it very clear to me how much we don't know about the ocean system and why fundamental programs around discovery like this ones are so important. Now, my task here is a little bit different. I'm going to try to take the other end of the approaches and trying to think about how we can take what we learn from fundamental science in these areas right down to realizing societal benefit and what's in there for the scientific community, maybe in partnership with the engineering community, but also how we can use that information to inform society in their, let's say, quest for dealing or interacting with our environment more sustainably. So I think there's an interesting connection, but you guys looked at it from a very small scale. I'm looking at it from a very large scale, but I think there's this kind of learning that we want to do here together. So the first question I want to answer with you, what the hell is a digital twin? Right? I think that is something 3 years ago I asked myself the same question, right? Because I'm not an engineer. I'm a natural scientist. I'm a physical oceanographer by training, not a life scientist, but we do discover the ocean. I could give great talks about, let's say, microturbulence and salinity and density and all of that. But that's a different community. This digital twins come from the engineering community. And what the engineering community does, it builds digital replicas of the things they want to engineer. Think of a train, airplane, think of a functional of a hospital, transport system of Paris. And the reason why you want to build a digital twin of it, you want to optimize the outcome without spending so much time building it in reality. So when you optimize an airplane and you want to go from aluminum to carbon fiber, there's many questions you have to answer. Some of them you have to do in the lab, some of them you can do on the computer. So I think in engineering, that's an old news, right? I could never stand up for an engineering crowd and talk about digital twins, and they're like, oh, that is really old, right? But for environmental science, we don't use that frame so much. So what are digital twins? These are virtual representation of the real thing. In my case, it's ocean here for this discussion. So we're thinking of the ocean system, and a digital twin takes the ocean into the digital world. So we're making a digital replication of the ocean. And what do we do with that? We're trying to build it out as good as we can, and we use it to optimize outcome. This is very different as to what you talked about. You talked about how does the system function, what do bacteria do, and what is their role, right? Now here it's intervention-based. Engineering is about how you can optimize an outcome. So the connection to your talk would have been, if we like a certain type of bacteria, can we enhance its growth? Can we bring it more to the environment, and is that a good idea or not, right? These are the kind of things that digital twins allow you to ask. So we call them what-if questions. I'm going to go a little bit deeper into that in a moment. But the frame within which this particular program that I'm heading is called DITTO is around this what we call the UN decade, United Nations decade of ocean science for sustainable development. And I think it connects to the talks that we just saw in a moment, is how can we use the ocean science and all the knowledge that we generated to inform decision-making about sustainable development in the ocean sphere, right? So that's this UN Decade of Ocean Science for Sustainable Development. And let's take a little bit of a look of what that is. And I have one slide on that, very simple. It's a very simple vision. The science we need for the ocean we want. So, Astrid, you didn't talk about the ocean that we want. You talked about the ocean that there is, right? But the question is, as humans, we like the ocean to be productive, supporting our lifestyles. Maybe we like it for vacation purposes, for transport and the like. So we have an idea of what kind of ocean we want. And in some senses, what does that mean for ocean science if we have a certain ambition of the kind of ocean that we want to preserve, maybe, or optimize? So that probably means you have to change our science, adding to the discovery that we just heard, also something around solution orientation. But it's also connecting people and ocean and all those actors who are in that space. So it's not just the natural sciences that we just heard 2 talks about, but it's also economic, ocean policy, ocean governance, and the ethics around it. Is it actually okay to increase the killing of bacteria? Are we allowed to do that? Is it our right as human beings to deprive the fish, let's say, from some of their benefits, right? So these are really interesting questions. And the Ocean Decade brings these type of things forward. It started in 2021. It's going to last to 2030. I have a little film that introduces the Ocean Decade that was virtually launched in Berlin. So let's look at the 2-minute or 3-minute of that film. I hope the sound is on. They promised me it'll be on. No sound. What happened? Okay, now I try to narrate, no, but that's really bad. Technical people, can we have the sound, yes or no? Audio? Because there's a little bit of, text to read below, but otherwise I'm just narrating it a bit. That's a beautiful picture of the ocean, right? That's good for the non-oceanographers. So, this girl, Angela Merkel used to be our president, so she thinks Germany is good in ocean science and we're contributing to that. And you see some pretty pictures of the ocean. And Vladimir, he's the head of the IOC, we need to live in harmony with the ocean. And Gutierrez says, time for revolution of the ocean. And this revolution has a name, the UN Decade of Ocean Science for Sustainable Development. I never narrated this, it's kind of all right. So let's discover into the science, and then it takes a big journey. Audrey, right, Paris here says, it's a unique opportunity, the decade, to really bring us advance from the UNESCO perspective. So, Maria Gabriel, Commissioner for Research, and she says, for Europe delivering the Green Deal, there's an ocean dimension to that, and I think the decade helps with that. So here's the G7 speaking, and Gideon Henderson, and he basically says at the G7 level, ocean is important, ocean and climate connections. You know this guy? Yes, exactly, the prince. So it's Peter Thompson, the guy who takes care of SDG 14, and he says you can only get to that by ocean science discovery we just heard about. So there's many actors, and Seychelles says we don't have time. It's an urgent topic, right? Pretty clear, we have to act now. What I loved a lot is this guy, Stuart Minchin. He's from the Pacific community, and he talks about local and community knowledge. And watch what they say. I mean, beautiful pictures for sure. But I think he talks about this guy, a naturalist, he says 7 generations ahead. We think 1 election cycle ahead, 4 years, right? He says 7 generations. And they talk about Maui, these places where they stop fishing. We call them marine protected areas now, but the traditional knowledge is already built into that. It's taboo. Nobody touches the reef, certain section of it. We have so much legal questions around protected areas now. In the old days, you just say, don't go there. So Antje talks about trying solutions, how can we deal with the ocean, polluting it less, you have to learn to be resilient, talking about the ocean, talking about it. But I think here Taylor is an early career ocean professional. It needs to be our job to think about these solutions. And the industry people say, for us, it's about transforming the business to be more sustainable from the ocean business community. So I think it's a very exciting decade that brings to all these different actors. Here is again Guillermo Ortuna Crespo. He's another early career ocean professional. And the last one I had, it's time to think how we communicate about the ocean. So there's different calls of action in this ocean decade. So the Ocean Decade is, in my view, an interesting frame that brings in the different types of sciences, some of them we're hearing here, towards our common goal, towards informing society about what we know about the ocean and how can we do that. There's certain elements around it. I'm going to give you the scientific version of that. So what are the scientific elements in that? It's about pollution and contaminants. A lot of pollution goes into the ocean, mostly land-based. Do we know what it is? Halfly. What can we do about it? How can we reduce that? We certainly do know how to reduce it, but we need to talk to land-based actors because for them, the ocean is the big drain. It goes into the big ocean, who cares? We do care. The second is about protection, monitoring and managing the ecosystem, the biodiversity. Chris gave us all the great reasons about why the biodiversity is so great. But the question is, can we protect it? And just a few weeks ago, we signed the first agreement that you can actually have a protected area in the high seas. You can talk to me in the break what that means. Then it talks about sustainably feeding the world's population. I think you mentioned food production, right? So the question is, what is the opportunity of the ocean? It can't be just fish. It needs to be lower trophic levels. It needs to be new foods. But the ocean has a lot of nutritional potential for that, so how can we think about that? It talks about equitable and sustainable development of the ocean economy. So it's using the ocean in a sustainable way. The other sets of questions are the ocean and climate nexus. I don't have to talk to you about that. We covered that yesterday a lot. Multi-hazard warning system for coastal communities. Ocean observing systems. You can't get to know what is happening in the ocean without having assets on the ground. I'll mention that a bit more. And it does talk about a digital representation of the ocean as one of the 10 goals. I'll speak a bit more about that in a moment. And then the last two ones are really, and when you work at the UN, when you work at UNESCO, it's all about the kind of thing that this program does a little bit about, but maybe can do more about. If the UN mantra is leaving nobody behind, what that really means, it means the scientists from all countries of the world should have equal opportunities to do the discovery, the solution orientation. Now we know in this program, the member states here have much more capabilities than small island development communities. So the question to us is, how can we make that possible for those people to come to our labs, for the knowledge that we generate, share with the global community? I think it's an interesting challenge also for this particular program, how to do that. And last but not least, it's the question that we heard yesterday so much about. Sometimes we know what to do. Reducing our carbon footprint as an example, polluting less, and yet it is so hard to do. Why is it that it is so difficult? Why don't we want to change? There's a lot of interesting science also in the ocean domain that can be looked at. But my brief today is, again, coming back to the digital twins of the ocean, and I really want to give you some examples of how these digital twins of the ocean can work with that agenda, can set in value the fundamental science discoveries that you talked about and bring it up to scale, and how these digital opportunities can help us with that. I think you gave some good examples how that can be done. So let me look at this from a more holistic view. Who benefits from that? Science, for sure. I'll give you an example of that. Governments, yes. And I'll give you another example, because if you own a bit of ocean, we call it the economic zone of the ocean, you want to know how to use it best. So we call it sometimes marine spatial planning. Civil society, discovering the ocean, learning what's there, are interested in that. The private sector will use digital twins a lot for their operations. I'm giving you an example or two in a minute, but it's also a tool for education. So I think digital twins are quite prominently there. And what I want to give you a difference between typical ocean models and digital twins. So in typical ocean models, we use them sometimes for what we call ocean forecasting. Think of weather forecasting for the ocean. So how does that work? It basically says, what are the questions? You want to know when a tsunami comes. You want to know when is a great beach day. You want to know when your salmon farm is impacted by lice and viruses. You might want to know how to optimize ship traffic. You might want to know how to manage pollution sides of things. And the way you do that is you have data from the ocean, space, and in situ. Giving you a picture in a moment. You use that data, sharing them, adding value to them, feeding them into forecast models, and you do a weather forecast for the ocean. And then you put that information out there, and then hopefully users can use that information for early warning systems, for optimizing ship traffic, and the like. But mathematically, what you're doing, you're asking the question, what is the state of the ocean today? How will it change tomorrow? It's what we call an initial value problem. So you want to know what the state of the ocean is, and you use ocean dynamics and ocean physics and ocean biogeochemistry to move to tomorrow. That's that thing. In twins, there's one big difference. It's almost the same, but there's one big difference, and the difference is intervention. Here, you're using observations, you're using models, but you're doing it in what we call a scenario mode. And you're asking these what-if questions. So what-if question is, how will the ocean change if humans take a certain action? That is the question. Mathematically, it's what we call a boundary value problem, because you're changing the boundary condition as the system evolves, in difference to an initial value problem. So mathematically is quite different, and it's really exciting. And you might say, wow, that's very confusing.
About 2.5 billion years ago.
Oh, right. I wonder where that came from, but that sounds fantastic. Now let me give you the most well-known prototype example of a digital twin of the Earth system. Pavel knows all about that. It's an Earth system model. And the what-if question that we started to ask 25 years ago, Pavel, remember that, is what would the global temperature look like if we put CO2 into the atmosphere? And you might be more specifically depending on how we do it, right? And typically what you do with that digital twin, so the model is an Earth system model, you initialize it with observations for today, and you're adding certain amounts of CO2 over time. And sometimes you do the green. That's the highly mitigated scenario, what the European Green Deal is all about. We'll see whether we get to that. Maybe it's the red curve here, somewhat mitigated, or the blue curve, business as usual, different scenarios. Unfortunately, because I'm using graphs which are from the community, that the answer of the digital twin has a different color code, but you can imagine which one that is. So the lower emission scenario, the green one is also the green, that gets you below 1 degree more than in the year 2000, so below 1.5, highly mitigated. Middle of the road scenario, we may be able to stay below 2 degrees, or you do business as usual, go up to 4. But it basically, this digital twin told you how the world will look like if we act a different way. And that's just carbon dioxide emissions, right? Typical what-if questions, typical digital twin approach. It's not a forecast, because we don't know in the forecast mode what society will do about CO2 emissions on anything around that. So that's example number one. Example number two is maybe more concrete. It shows you the power of digital twins. So now we're asking the question, take a coastal community. And here in the coastal community, you ask the question, what is the most cost-effective option to mitigate the coastal impact of sea level rise? IPCC told us, I mentioned that yesterday, that at the end of the century, we're going to get at least 1 more meter of sea level rise. We're committed to half, but that would mean Green Deal globally. That's, I think, it's not going to happen, so you got to prepare yourself for at least 75 centimeters, maybe a meter. So the question that you have as a coastal community, how do I deal with that, and what does that mean for me? The way you do it, you take these global systems, and you regionalize that. So you take a global model, regional, local model, and you get to a model that can really simulate your harbor, your estuary, something very close. And the what-if question is, so how can I protect my coastal community? You can either build a dike, you can build out sandbars, you can protect your coral reefs or mangroves, depending on where you live, so you have more than one option. And the interesting question is, what is the right way of doing it in my scenario? And a digital twin will allow you to do that. You can play that out and say, what if I put sandbars in? How about if I protect my corals? Maybe I increase the mangroves by certain plantations or other things. It's really interesting. Germany used that approach, not in the fully digital twin mode, but thinking it through. And Germany said, we're going to up our dikes. The Netherlands, where Pavel is about, remember the Delta report? They said, no, we're going to do that much. We're going to do our sandbars because we're going to protect ourselves from the storm surges. In Bangladesh, there's no way you can build up dikes. You're going to go for other solutions, right? So it tells you exactly that the answer is not unique. It depends on the setting that you're in. And a digital twin will allow you to do that in a much more, let's say, realistic way if you have a good understanding of where you are. So it's really setting in value the knowledge that we have at the regional scale to inform decision-making in this case. Another example is how can we best implement wind energy capture systems at sea? Huge issue. In Germany, my country, we committed to wind energy. We don't have the space for it. They're thinking hard about how can we do that, right? And if we put lots of wind turbines there, can we still have tourism? How about transport? How about other uses, including protection areas? It's a complicated mix of issues, and digital twins allow you to go into that. And then the next slide tells you a little bit more how these things look like. Now, the private sector loves digital twins of the ocean because they have digital twins of the turbines. Their question is, how about big waves? How about currents? How about noise pollution? How does that play out in the environment around our built infrastructure? So they want to couple their digital twins of the thing, the wind turbine, with the environmental twin to do proper impact assessments in design mode, right? Not after the fact. So I think these are some examples I think you can easily relate to. So what does it take to get these things to reality? What do you need to build digital twins? What are they built upon? There's no digital twin without an observing system, because remember, you're trying to build the real thing, the ocean, on the computer. You need to have a good understanding of the bathymetry, the depths of the water. You need to have a good understanding of the currents, of the water temperature, of the biology, of the biodiversity. So it's a huge challenge from a data point of view that you need to do. But it's obvious that the payoff of digital twins is grand also because it's a decision support system. So I think these digital twins will help us to get more buy-in to an ocean observing system because people will see the benefits from that. But you need that. So I think a co-design approach between those who have all these technologies, ships, robots, buoys, it's the stuff I do when I do my own research. But you can imagine, if you're not an expert, many opportunities there to look at the ocean from different ways. You showed some examples from Tara, and there's biological samples, eDNA, acoustics, new ways of doing it. Will be really fascinating. So I think we've got to work there with that community. There is no digital twin without an ocean model. And Chris talked about that too. We have decent ocean models for the circulation, the dynamics. We have okay ocean models for, let's say, carbon pathways. We have poor ocean models that capture biodiversity and the ecology. So the fundamental science that we just heard about in a moment will be really critical to build out these ocean system models to be performing, let's say, acceptably in some of these areas. But you need that, and I think artificial intelligence, machine learning, some of the new tools will be really helpful, in particular when it comes to biodiversity or complex interaction, let's say the killing between bacteria, right? I mean, there's no way we're going to model it down to the bacteria for a large scale. You have to parameterize it, and the question is, can we use what you do in your lab experiments, use AI to come up with some good algorithms that then can use to be scaled it up? That's the kind of frontier of science. Nobody knows exactly how to do that, but I think we have the tools to really make breakthroughs in that business. And I think in a few years, we'll have much, much better systems than we do it today. But I think that is the way forward. None of this, observations and model, will work if the data don't talk to each other. And colleagues, this turns out to be the hardest problem. Technical terms is called interoperability. And it's about, if you call a temperature with a small t, a capital T, a TP, a TA, a TS, to a computer that's 4 different things, your meaning was ocean temperature, right? So how can a machine understand that I'm talking about an ocean temperature if we each give it a different variable? Now, temperature might be easy. Let's talk about a bacteria, right? Some of them have unique names, some of them don't. So interoperability is we agree on standards what to call things, what units we're going to use, and we make these standards globally. This is the hardest problem. But only if you do that can you actually share the data globally. If everybody uses their own definition, a machine will not understand that, right? So interoperability is really important. And we want to make this data available to all. So we need to democratize the data world. Don't put IP around it, very much done in life science. You know, it's my organism, it's my IP, it's my patent, nobody's allowed to use it. That's not going to help us here, right? We want to share the information. So that's important. But more, or as important, if you have standards and openness, then we can build trust. If you have a lot of IP around and say, well, I can't really tell you how I did that, that's not going to be a trusted data set, right? You've got to be open. Because trust will be the most important thing. If it's flooded with fake data, such a digital twin, it'll be wrong, right? So how can you build trust in the data that we have? And we need to ensure wide and equitable access. There's some international programs that look at that, but I think that is in somewhat, for us in the scientific community, hard to do. Some communities have done that very well. Genome, it's done very well, and other communities, not so much. So, but I think the exciting way forward is this. How can we visualize the information coming from digital twins and make it available to non-experts? And what I think is delivering twin information in what I call a decision-making theater. What do I mean by that? This is something, it's a picture taken at GEOMAR. We have a system that we call Arena 2. It's a 120-degree dome, like a mini planetarium, where we can visualize the thing that digital twins do. And this particular photograph, the decision-making theater asks a very simple question. They're visualizing a high-resolution bathymetry map that was taken with a robot. And the decision that these guys are making as they and girls, they want to optimize the next expedition. And they want to think about how does a ROV grab a sample here and there and something like that. So they're using that in the collective, visualizing it, the next expedition, because it's so costly. So this is done in the science. But imagine you can visualize your port, your coast, and certain development scenarios, asking the question, we're going to pollute more, we're going to pollute less, protect here, have industrial development there. So I think it's really visualizing that. And digital twins are really powerful in that view. So I think visualizing is going to be very important. This can be through browser-based, Jupyter notebooks, but it can also be 3D immersive. And we're working with the gaming industry huge interest in that. And the gaming industry is fantastic in visualizing things also in virtual reality. Imagine, Pavel, we can take the ocean 20 years into the future under certain development scenarios and actually watch it. Dive through it, look at it. I mean, that is the power that digital twins will give us in the scientific community, but also talking with decision makers. So I'm giving you one last example, and then I have a few summary slides. So here's a part of the Mediterranean. You see Italy there, Croatia, and some of those countries. And in this part of the world, they're building a digital twin of the Adriatic system to optimize what they call marine spatial planning. They have many uses of that system, often conflicting. And the question is, what are we allowing where? It's zoning, right? We do it on land all the time. In the ocean, it's not so well done. And the point I'm trying to make in this middle graph here, we used to do zoning when I was a student. You have a map. And Pavel, we used to take a pencil and draw on the map a red and a green and a blue, said this is sort of where fishing is, this is sort of where transport is, so we do pencil on a map. And when I was a student, there was a mathematics student, and she told me, Martin, I'm working with the geographers on this thing that they call Geographic Information System. And the colleagues from the geography department said, I cannot run this, I don't know what it is, you need an informatics expert, but somehow we can put colorful maps on top of each other. Now today, a geographic information system is the standard tool that everybody uses around the planet for spatial planning. But I think digital twins will be the next generation of that, because the problem with GIS is non-dynamic, it's static, right? But imagine you can do it in a changing world, in a dynamic world. That is what digital twins will do us. So I think they'll be the next step up from drawing pencils on a map, doing GIS systems to really three-dimensional moving environments. And I think digital twins will deliver that for sure. So internationally, we have summits of that type. We had one last year in the UK in a very nice location. So if you're interested in that, you can look at that. The G7 sponsored that. That was the beginning of that. And we had in-person events and virtual events. It was still Corona times. And the next summit is coming up in China, November 9 to 12 in Xiamen. So I'd like to invite all of you who are interested in learning more about that. Look at the summit. You can still submit an abstract. I think it's going to be a very interesting discussion with the various actors in this digital twin community. And what we're doing at this international level, we have certain working groups advancing digital twins, setting standards, making the community aware, sharing best practices, and so on. So for those of you who want to engage with us, you can become a partner of this, so go to our website and register if you want. You can join the community. There's more partners already than we have here, and it's a really interesting group. It's not only academics, it's industry, it's government people, decision makers, and the like. So, colleague, summary. I love fundamental science. That's how I made my career. But I do think that fundamental science can also, in addition to advancing that, contribute to solving big problems. And the way you do that is not to write a Nature paper. I love Nature papers, but don't get me wrong. But you've got to go through assessments. That's one way to do it. And people do read. I mean, we heard yesterday a show of hands who read this IPCC summary of the IPCC, right? I mean, 30% did. And it's tough to read. But I do think these engineering tools like digital twins, they bring the value, the data much more to life towards a real concrete decision-making question. And that's why I'm pretty excited about that, because it helps us to set in value investment in fundamental science, how it can transfer right through as what I call a decision support system. And I do think digital twins can really help us to future-proof sustainable development options. And thanks for listening.
Thank you, Martin.